At this time, let's begin today's ATIS webinar, Mitigation Techniques for Unwanted Robocalls, Updates on ATIS, and Other Key Industry Initiatives. It is my pleasure to introduce your moderator for today, Jim McEachern, Senior Technology Consultant with ATIS. Jim, the floor is yours.
Thank you, and welcome everyone to today's webinar. As I said, my name is Jim McEachern with ATIS. Our panelists today will be Martin Dolly with AT&T, Gary Richnacker with iConnective, and Chris Wendt with Comcast. Before we start, I want to just take a moment to say a bit about ATIS for anyone who's not familiar with us. ATIS brings together members from all areas of the ICT industry. That includes service providers from all segments, wireline, wireless, cable, and internet. It includes solution providers. It includes equipment manufacturers and software vendors, and many more. The goal of ATIS is to address the most pressing problems facing our industry, problems like robocalls, which brings us to today's session. So I want to provide just a bit of an introduction. As I'm sure everyone is well aware, caller ID spoofing and robocalls are getting increasing scrutiny in the industry, really from all angles. Regulators, legislators, consumers, advocacy groups, the media, and of course users themselves are well aware of this. ATIS has a number of programs and has had for a while a number of programs addressing robocalling and caller ID spoofing, and really looking at a range of techniques that address this because it is a complex problem that affects all aspects of the industry. And the objective really is to provide the users with meaningful mitigation techniques. And you'll see in our session today, the users play an important role in mitigating for caller ID and caller ID spoofing and robocalling because they ultimately control what calls they receive. Finally, I said ATIS has a number of efforts. These efforts have been going on for some time, but it's very fair to say that since the FCC robocalling strike force was launched this summer, the recognition and the visibility of that efforts has increased dramatically. And today we'll give you some further insight into that. So the level of awareness of robocalling and the industry activities has increased dramatically since this summer, but the activities have been going on for some time. And I want to just quickly go through this timeline. Basically, you can trace back to at least the FTC workshop on robocalling, which occurred in 2012, October 2012. Which led to a call to action from Professor Schultzring, who was the FCC CTO at the time, in March of 2013, which led to an IETF birds of a feather on approaches to calling ID and the chartering of the STIR working group in August of 2013, the Secure Telephony Identities Revisited. Shortly after that, ATIS and the SIP Forum collaborated on a IPN and I task force, and one of the things it did was tracking IETF STIR. And in August of 2015, it went from tracking STIR to focusing on solutions for robocalling. The FCC had a workshop that fall. ATIS filed an ex parte shortly after that, and then beginning, although the ATIS SIP Forum IPN and I task force work on Shaken had initially started as an alternative to STIR. In the fall, discussions began to in fact merge the two, so it became a profile of STIR. Activities continued on this, and as you can see, through to ATIS published a couple of white papers dealing with aspects of this, raising visibility and analysis. And then in July, the strike force was launched after the FCC reached out to carriers, and that kicked off in August. And I think that should bring you up to now, and we'll go through some of the work that's been done since then and where we're at today. And with that, I will hand it over to Martin Dolly to provide us an update on the standards. Martin?
Okay, good afternoon, everybody. I'm Martin Dolly, lead member of technical staff in the AT&T Core Network and Government Regulatory Standards Group. Okay, so to start off with, there's always been confusion for a while with what is the difference between a spoof call versus a robocall. The truth in caller ID prohibits spoofing or deliberately falsifying the telephone number and or name relayed as the caller ID information to disguise the identity of the caller for, and here what's important, for harmful and fraudulent purposes. The law applies to callers within the U.S. The important takeaway there is that it's not illegal to spoof your number. I could have called Jim McEachran and showed a number of Barack Obama to show up on his phone and then say, ha, 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 I got you, as a joke, and that's okay. That's not illegal. It's only illegal if there is harm or fraud associated with it. And maybe to highlight here the difference between the techniques that can be used for email and messaging services is email and messaging services are store and forward type of services. In addition, there is no law that prohibits looking into the content. And so therefore, before delivering those type of services, the ability to look into the content to determine whether there would be any harm or fraud can be done. As we know for voice calls, that is something that cannot be done. Setting up a voice call, whether it be VoIP or circuit switch, is a real-time service, and the timers in the technology are unforgiving. Plus, the law prohibits us for looking into the content. And so, as it relates to reporting whether there was harm or fraud, this can only happen after the fact and reported by the user. Okay, and so, and then there's robocalls. And this is, the robotic dialing. It may transfer you to a person if it recognizes that you picked up, but it's computerized auto dialing to deliver a pre-recorded message as if from a robot. Robot calls are often associated with political, telemarketing, phone campaigns, and they can also be used for public service and or emergency announcements. So the latter part are legitimate uses of robocalls. Okay, so how do we get here? Robocalls and spoofing is the #1 complaint to both the FCC and the Federal Trade Commission. Provided here is the URL of articles, complaints to Consumer Reports. It's not just an issue here in the U.S. Robocalls and spoofing are the #1 complaint in Canada to the CRTC, as well as Ofcom in the United Kingdom. Okay. Next week, we'll be bringing in for making enhancements to signaling, and I'll touch on that a little bit later, a work item, discussion paper, and change request into 3GPP. And hopefully out of that discussion, the list of countries, to this list will grow. There's been endless hearings in Congress. With voice over LTE, based voice will be 75% of the market within 3 years. We know that the existing Class 5 PSTN, it's near its end of life, and these types of equipment cannot be modified. So when looking at the solution space, we have to take that into account, that we can't modify equipment on code to which the developers aren't around anymore, or the compilers. And going to next slide. Okay, so within the ATIS PTSD, we had a technical assessment looking at the solutions, or what we refer to as mitigation techniques, because there is no single solution to the robocalling spoofing problem. And so just like cybersecurity protection against robocalling, just like cybersecurity, protection against robocalling and spoofing has no silver bullet. It can only be realized with a layered approach of mitigation techniques. And, when I presented at the FCC panel back in September of last year, the use of the term mitigation techniques became part of the lexicon on this topic, and this came out of the ATIS work. Even with the development and deployment of STIR-SHAKEN framework, traffic from circuit switch originations and IP gateways, both international and wholesale, will be an issue for robocalling/spoofing. Therefore, deployment of other mitigation techniques and a layered approach is required. Something that's very important is that an ecosystem associated with addressing these problems, there's a role in it for everybody. For the FCC and Federal Trade Commission in prosecuting bad actors, the carriers in deploying appropriate layering of mitigation techniques to protect their customers. These include techniques provided by third-party providers, as well as the consumers. The consumers need to learn via education from both the government and the carriers on how to manage their communication and to choose to block the call. And what's important here to take away is that it's the consumer that has to choose to block calls towards them. And there's been some recent rulings where this is allowed, where if the consumer says, block these phone numbers coming to my home, like IRS numbers, the carrier can legitimately do that, but they're doing it with the permission of the consumer. Okay, so continuing, part of the layered mitigation approach that was recommended within this assessment was the deployment of the STIR-SHAKEN framework. Chris will speak to this in a lot more detail coming up in subsequent slides. STIR, as discussed previously, was developed in the IETF, and the SHAKEN framework, as Jim described, started out in the ATIS IPN&I. Some form of post-call reporting is a must, whether it be a web portal, a call center, or in or post-call type of signaling. In order to do the proper reporting to the Federal Trade Commission so that they can follow up and do the appropriate enforcement. And we'll discuss a little bit more about this in the subsequent slides. Operational CDR tracing, which provides a mechanism for identifying the source of the calling party number in both CSPS and across CS and PS domains, that's circuit switch and packet switch domains, is also required. Though parts of this can be automated, most of this still remains manual. But it's an integral part of the solution. In addition, something to note that there is an aspect of traceback associated with the STIR and SHAKEN framework, and again, Chris will talk about that with a bit more detail later. Do not originate servers. should be deployed at IP gateways. Okay, so whether certain VoIP gateways, and particularly international gateways, you shouldn't be expecting calls for 911 or coming from government agencies coming in from these sources. And so therefore, there's an effort to create a list so that carriers can uniformly, block these types of calls. And then there's the use of blacklists and whitelists, which are useful, but they require further data analytics in order to be effective, and we'll touch base briefly on that in a bit. And service providers can verification of numbers originating from IP PBXs. They can do a further verification of the number in their application servers with respect to the TNs that enterprise and or wholesale customer could use. Okay. All right. So with respect to stir and shaken, as I mentioned earlier, there are limitations to what stir and shaken can do. The stir and shaken is really applicable for calls that originate and terminate on IP. But they can also provide for traceability purposes, identify calls coming in from gateways, whether it's a VoIP gateway or an international gateway as shown on the left. In addition, as shown on the lower left, data analytics servers or anti-robocalling apps could then take information with respect to what is being attested to in stir shaken, and Chris will talk more detail about the attestment in his talk, in the data analytics in order to determine whether this is a spoofed or robocalls. Calls from outside the SIP network cannot be verified. Domestic SIP only, and no support for TDM, though as shown in the previous view graph, this will likely be extended to Canada and the UK, and as other countries get involved, we are standardizing within 3GPP as well as the IETF in order to have global standardization solution to the problem. Okay, so speaking to that, the IETF stir drafts, the base drafts for the authentication verification are the 4474 bits, the passport document, as well as the stir certificates document. And so these three documents make up the base or foundation to which the work in the ATIS SIP Forum Task Force is profiling in Shaken and in a subsequent document on the certificate framework, governance, and policy work that got kicked off at last week's meeting, and hopefully will go to approval within the IPN&I Task Force at the end of the year, latest first quarter next year. In addition, there was a IETF draft recently submitted by Professor Henning on a response code for unwanted calls. Okay, so tongue-in-cheek and typical IETF style, the response code chosen was 666. And so the idea, and I'll touch base on this in a a few subsequent slides, is to, on the user's display, in addition to the accept or the green and red button, to include a button on the phone or on the user's device where they can report that this is an unwanted, spoofed, robocall to the network. The device would respond to the network with the 666, and then the subsequent, traceback and reporting would occur at the terminating network operator. This other draft, which is the SIP call info parameters, here we're talking about parameters that would be byproduct of data analytics and the like. And so this document here will feed into the authentication function or verification function, communicating either in serial or possibly in parallel with some data analytics server that would provide further analytics to the user, possibly resulting in some illustrative figures coming up that this is a possible spam to the end user. In addition, moving down past the Shaken, which again is the profile, within the ATIS PTSD, we just sent a doc, and Shaken went to letter valid approval last week, and so did this technical report on the use of an ISA screening indicator for conveying authentication information. The FCC requested that we look at interworking the fact that a call has been verified in the IP space, interworking that into the circuit switch ISA protocol, and particularly within the calling party number, there's a field called a screening indicator. And so is it possible that we could do interworking into that screening indicator in order to convey better integrity of the calling party number, to users within the circuit switch domain? This technical report provided the analysis. This analysis was handed off to the strike force, and I'll say nothing more about the strike force today, for the strike force to make a recommendation to the FCC. And so this analysis is available out for letter ballot within the ATIS procedures at this time. Within 3GPP, SA1, where they do the service requirements, change requests have already been approved at their August meeting. Going into the meeting next week in China, I have a work item request, CRs, as well as a discussion paper, and would like to thank several companies, particularly Ericsson and Nokia, for their support in this effort. And then subsequently, and that's the reason for the work item, we expect additional CRs into 29165 for NNI, as well as enhancements to the specs to cover the caller info, spam work, as well as the unwanted call work within the IETF. Okay, so signaling, verification, and analysis analytics. Again, Chris will talk more about the stir shaken. Okay, so SIP invite comes into the IMS, or it could be any soft switch type of architecture. You're going to have a verification function. This verification function may or may not interact with data analytics. So initially, there may be no interaction with data analytics. Over time, there likely will be. And there may be some data analytics embedded within the verification function. Again, Chris is going to talk more to the attestment, but one of the things which is a full attestment could result in a signaling from the verification function through the IMS toward the device that this number has been verified. And so with respect to signaling verification, the syntax for the veristat field is going to be a tell URI parameter in the p-asserted identity or from header. And it has the syntax shown here with TN verified pass, TN validation failed, no TN validation, and possibly in the future have similar values for CNAM. Whether something is signaled to the end device is going to be based on local policy up to the carrier in their verification function, and as well as what's going to be displayed within the IP and NNI task force in order, under the umbrella of keeping it simple. There was consensus of something like a green circle with a yellow check mark in order to make it very easy for the user to recognize and to, when you pick up your phone, you're just looking very quickly, and so not providing a lot of information that's going to confuse the public. We also address security considerations. So with respect to, what if a rogue node or device started generating this parameter? So within our security considerations, the verification function must drop a veristat tell URI parameter received in an invite. If the terminating UE does not support the veristat parameter value, it must discard the parameter. And this is basic SIP protocol design. If you don't understand something, don't throw the message away, but just discard the part you don't understand. And to protect against the rogue signaling, the terminating UE will act on the veristat parameter value only if the 200 OK to the user device registration includes a feature cap header field as specified in RFC 6809, and the encoding is plus g.3gbp.veristat header parameter. Okay, so within the IP NNI task force, we had a signaling display document that got put on hold with the advent of the strike force. That document is going to be resurrected once the strike force terminates on October 26th. Some of the discussions within the strike force was to provide enhanced CNAM, which was defined within ATIS PTSC and further within the IETF to extend on the limitations of the 15 ASCII carriers currently. As I mentioned before, a presentation to the user could be the simple check mark. You could also add within the call info header some additional enhancement. So that could be provided by the network with enhanced CNAM. And also, as I stated earlier, the block caller or spam button. So if the user, when they get the call, if they think this is a fraud or spam call, they press that button, and 666 would get sent to the network, and again, that would initiate the tracking to the source, as well as reporting appropriate government agencies, FCC, FTC. It was also identified that we need to protect, GETS, which is Government Emergency Telecommunications Service users, or emergency personnel from revealing their true calling party number. So within the IPNNI, we have a use case document that addresses other use cases for the STIR, Shake, and framework. Some of those include, but not limited to, support of NSAP or the GETS users. It also includes extending this to SIP message, extending this to CNAM, as well as other services, and work on the use case document, and then future work providing enhancements will be done within the IPNNI task force. The work on the GETS, or Government Priority Services, NSAP, will continue within the ATIS PTSC. Okay. Display to users, other considerations, useful identification of the callers, authentication assurance, so providing an authentication assurance level to the user. This would be part of the more enhanced, spam indicator referenced in the spam info draft RFC. And with that, I am done, and I will hand off to Gary.
Thank you, Martin. And Gary, take it away.
Okay. For the next few minutes, I'm going to talk about one of the ATIS groups, the testbed focus group. Within iConnective, I'm a principal solutions architect. I work in the CTO group. And my role in this ATIS committee is I co-chair the testbed focus group along with Mary Recca from CenturyLink. So when the testbed was being established, there were basically three major objectives. One was to create a collaborative environment for testing in an all-IP environment, and the other was to do validation testing or proof of concept, and the other was to facilitate really interworking or interoperability amongst a group of companies. So obviously, if you look individually within each company, companies really only test the components that's relative to their network, which is only a portion of the solution. So hopefully by creating this collaborative testing environment, we would also do end-to-end testing, and we would hopefully identify some gaps and maybe the standards early on, and that would just help the process. So when we were looking to define our work or the scope of work, we were looking at existing testbed activities, and we also requested companies to submit use cases to the group. And our testbed focus group, and I'll spend most of the time on the STIR, Shake, and testbed, but it incorporated other use cases, and we have 10 use cases, and they're grouped into numbering, routing, and the STIR, Shake, and authenticated caller ID. So if I look at how we developed the work plan, we actually put it in phases. So we broke it down into 4 phases, where phase 1 was a high-level system description of each of the use cases, a reference architecture that had the core components, and pretty much a high-level test plan. Now, what we meant by this first phase is we really meant to define and describe and provide enough information for companies to make a decision whether or not they wanted to participate in any of the use cases. And then so once we completed phase 1, which we did, we started to go into phase 2, and one of the things we did under the ATIS umbrella was to create an NDA for testing participation, and that really protects the company's intellectual property with participation. So, and we're really in between phase 2 and phase 3, where phase 3 would be intercarrier or intra-carrier and intercarrier testing, and then obviously phase 4, we would develop and submit some reports based on the tests themselves. So if I look at the test case scenarios, I did want to mention that there are 4 active ones with multiple participants, and I'll just briefly describe what they are. One is for numbering assignment for just-in-time numbering or individual TN based on a distributed service bureau, and what that really means is that there would be peering between the service providers during the provisioning of numbers. In addition, one of the other nearer-term things is how do we do that really with utilizing, enhancing, modifying our existing systems. There's also one under routing for upgrading the LERG for IP enhancements to include other IP identifiers that could be used in routing. And the fourth one is what we're talking about, and I'll focus the rest of the presentation on this, is really the STIR protocols for end-to-end IP calls or end-to-end SIP calls. Now, one of the things to mention is through the testbed focus group, each of these tests will occur in a phased approach, and each with its own timeline. And one of the things about the STIR Shake, and it's got a lot of attention and a lot of activity. Martin mentioned with the IPNNI, Jim mentioned a lot of the ATIS groups, but there was another ATIS group called the Calling Party Anti-Spoofing Landscape Team, CPAS, and they produced a white paper. So with STIR Shake, and we're going to align ourselves with the recommendations of that. In addition, what Martin talked about and what Chris Wendt is going to talk about is to support the ATIS SIP Forum IPNNI Task Force protocol work and the specifications that are being defined there. So we view the testbed group as really providing a clear benefit and value to the ATIS membership. Now, in terms of call flow for testing, and Chris Wendt's going to get into this more in detail, and my intent is not to go through the call flow itself, but this is what the entire solution that we hope to test within the testbed and all the various components, the interoperability, and the signaling. So just a few notes. This is really based on the IMS architecture, and as you can see, this represents new call flows and changes to SIP signaling. So hopefully in this collaborative testbed environment, we can test up front some of these, all the various components with the protocols to do validation. So for the next steps, what we will do is we will finalize phase 2, which is finalizing the detailed test plans, and also at the same time soliciting additional industry participation if they care to be involved in the testing. So obviously the phase 3 is conducting the tests and to validate the protocols, and I just wanted to mention, like I said, that each of these use cases has their own timeline. There has been some testing up front, and initial testing has begun to validate the protocol. But we like to do additional testing for interoperability with all the various components. And so it looks like sometime in late 2016 and into 2017, that additional testing, that interoperability and interworking testing will occur. And then after that, phase 4 is we will issue some reports. So that ends my prepared part of the presentation, and now I will turn it over to Chris Wendt.
Thanks, Gary. Yeah, my name's Chris Wendt. I am a director at Comcast and manage some of the strategic things we're doing in IP communications, as well as look at and participate in some of the standards bodies. Specific to this is IATF and the NNI Task Force, and I'm actually one of the authors of some of the IATF documents, as well as editor of the Shaken Draft. So I'll try to give a little bit more depth into the protocols that are involved and discuss some of the key points around this. Just to start out, the high-level call flow for STIR as well as Shaken is really one way you could look at it as the parallel of web PKI in the browser world. So, for example, when you're talking to when you go to your banking website, you see a little lock symbol, and that's based on PKI or public key infrastructure with a basis in certificates. So in the STIR framework, we have a similar premise where if a customer of service provider A initiates a call, there's an authentication service that will put a digital signature based on a certificate that that service provider A manages, and also has been signed by a trust anchor, the trust anchor representing the authorization that the service provider A can initiate a call onto the telephone network. And then the call is routed through typical IP mechanisms to the destination service provider, and the destination service provider hosts a verification service which can look at that digital signature, access the public key, verify that all the information is correct in that digital signature or token, as I'll explain later, and then makes a determination, hopefully if it's a fully signed call, then everything's okay, and can deliver the call to the end subscriber. As Martin mentioned, there's two, at least from the protocol perspective, there's two key specifications in IETF that detail this passport, which defines a token format based on a fairly popular mechanism called JSON Web Token. And then RFC 4474 BIS is the actual protocol that defines how passport will be used in a SIP message. So I have a small example here of a SIP invite. And there's a way to map the information that's in the SIP invite into the token that is going to get signed by a digital signature. And then that information, once it's verified, can be inspected back into the SIP invite, make sure that nothing has changed or tampered with, or that the date corresponds with the signing of the call. And then everything is validated correctly. So Shaken is a framework that we have created in the NNI task force to define both how the inner working, how we're planning to deploy it as a industry, as well as some additional factors for making sure that the validation of how the call originated is correct. So in the Shaken framework, we've defined a passport extension. So in the core, let me go back one slide. In the core specification, we signed the origination number and the destination number and the date that it was sent. We've added some two new extension claims. One is attestation, and I'll explain a little bit more about that in the next slide, but it's an indicator representing what the service provider knows about the origination of the call, as well as an originating identifier, which is basically a unique, globally unique identifier that service providers can use for really two reasons. One is an identifier that can represent where in the network, either a node or from perhaps a trunk or a wholesale customer where that call was originated, as well as a constant identifier that can be used for part of the analytics work that's being done. So it can be tied to a reputation score. So on the subject of the attestation, we define 3 levels of attestation. So when the originating service provider originates the call, we know certain things about how that call was originated. And for A, the full attestation, we're saying we know who originated that call based on some authenticated relationship. We also know that the telephone number they're using for that call is valid, either because the service provider has given them that number or they've established some verified association with that telephone number. The B level is partial attestation. So this is basically we are responsible for originating the call. The service provider is responsible for originating the call based on customer relationship. It's an authenticated relationship. However, the caveat to B is that we haven't established a verified association with the telephone number being used. So for spoofing scenarios where that telephone number cannot be validated or has not been validated, we would give the B attestation. And then the C level is the gateway attestation. So that is for scenarios where we basically have, a call has either come into our network and we don't know where it came from, or we basically have no idea or cannot attest to anything related to that call. So here's the full Shaken Passport extension with the ATIS and Origin ID payload, just as an example. We also have started the process of going over the certificate management framework. So we had an initial proposal for the core telephone authority certificate management framework, where it's sort of a traditional certificate authority relationship. So service provider manages private keys. It gets the certificate countersigned by the trust anchor, and then gets that back and makes the public key available to verification services, and then manages the private key so that it can sign on the authentication service side. We've also started, so we've started a new document that we're targeting for end of year, with the certificate governance model as well. So the ability to originate telephone calls onto the network is obviously not a free-for-all. So there has to be some security that is applied, as well as how those telephone authorities are administered, and the service providers are given the credentials to access that certificate authority capability. And then just to review at the end here, as Gary showed before, there's a full call model. This is done in the context of IMS architecture, but you have the certificate provisioning service represented at the top, as well as the certificate repository that verification services can access the public keys certificates to verify. And if you follow the call flow, it's basically, it's a basic A to B scenario. So the STI-AS is the authentication service, the STI-BS is the verification service, and we have a black box type of function we call call validation treatment, which is basically the analytics that Martin mentioned in the beginning. And that's where you take that validation information and other information and make some determination of how you want to treat that call and how you want to represent it to the user. So next steps, as I mentioned, the Shaken framework documents, or the main Shaken framework document has been sent to letter ballot. in IETF. All the relevant documents are in working group last call, so we anticipate that getting done, and we are going to quickly finish up the certificate framework for targeting the end of year. That's it for my presentation. I'll hand back to Jim. Thank you very much.
Thank you, Chris. We have a few minutes for questions. If anyone has any questions they want to submit, on your lower right-hand side of your screen is a Q&A button. We have one question that we've received. Just find it here. How do you address false or erroneous or willful reportings? I'm assuming that means if someone flags a call as being spam, either accidentally or maliciously, when it is in fact from a fully valid number, how do we deal with that? Chris or Martin, do you want to comment on that?
I think.
Okay.
Okay, go ahead, Martin.
Yeah. Okay. So there is some discussion going on the IETF mailing list with that. If the user does report that this is an unwanted call, it doesn't automatically go on any global blacklist. There would be some traceback and potential reporting, but there's going to be further investigation prior to totally blocking a number. For instance, if someone doesn't want phone calls from their ex, that number is not going to be put on a global blacklist. There's going to be some intelligence in the analytics with respect to actions taken, but it will initiate the process, as I mentioned, with respect to doing a traceback and doing reporting.
Thank you, Martin. The next question from Simon Yu is, when a call is redirected, how is the passport in the invite changed? Chris, you may want to tackle that one.
Yeah, so if a call is redirected, it would have to be some further actions taken. So the premise that we put forth for now is that the call should be validated before any application function does that. There is techniques that you can use to perhaps re-sign it and include the identity header. So put a new identity header at the redirection. We will probably cover that in some of the use case documents that are coming later this year, going into next year. But for now, the basic validation should occur, and then you would add to that either through additional identity headers or other application-specific functionality.
Okay, thank you. And just if the presenter could move to the final slide, one of the questions I had is, will the presentations be available afterwards? And the answer is yes. This will be recorded and the material will be available. A couple more questions. From Brent Struthers, can you give a real-world example of a call flow that might get a B or partial attestation?
So,
Chris, I'm guessing. Yeah, go for it.
Sure. So B attestation represents basically, maybe premise that we want as many A attestations as possible. But I think the industry will have to probably look at their policies in terms of originating calls with validated numbers. That's sort of, I think, part of what we plan to address as well in some of these use case documents. But it's pretty clear that you don't want to be sending calls, if at all possible, with spoof numbers that you haven't validated with your customers.
Yeah, and if I could add to that, what we agreed to at last week's IPN&I meeting with respect to work going forward, and Chris and I had a brief phone call on this earlier today, is we're going to create best practices with respect to the attestation to give guidance. And as it relates to some of these other topics of the actions taken for reporting, starting in the beginning this year in the fourth quarter and going into next year, the IPN and I will be progressing these best practices. And if you're interested in the topic, please participate.
Okay. One more question regarding A, B, and C attestation levels. Will there be flexibility in the protocol to easily add future levels? I would be concerned that threats will change over time. Chris, I think that's probably you.
So I think we wanted to keep it as straightforward as possible. Whether there's new levels, I think that will probably have to be evaluated on a case-by-case basis, but I think some of the granularity of different cases would also probably be handled in the analytics part as well. The nuances of looking at the call details and determining where it was originated and maybe other factors into providing more information, as well as some of the call info parameters. They may provide additional things that we would probably want to sign and validate coming from the originator.
Exactly. That's, I guess where I was going to go is that by the use of not so much changing or extending the attestation levels, but providing different types of tokens and signing different parameters would allow you to extend it in that direction, right? Correct?
Exactly. Yep.
We have a question on the roles of the governance authority and the TA administrator. You've commented that is a document that is just being addressed now. I don't know if anyone has any comments on how that would be filled going forward, or if that's one of the things that will be worked out as we move forward from now.
Yeah, I would, like Martin said, advocate and an I task force can either be participated as an ATIS member or a SIP forum, through the SIP forum fairly freely. So any opinions and folks that want to get involved would definitely be encouraged.
Thank you. And I think that is all the questions we have, and we're 1 minute past the top of the hour. So with that, I would thank you all for attending and thank our presenters for the presentation. Thank you all.
Great. Thanks again to everybody for your presentation today, and thanks again for you all for joining us. This does conclude our webinar. You are now free to disconnect. Thank you.
Thank you.